stars and queens and ocean in the sky. Purples and pinks flutter all so high for the team, aurora. Let's go team, aurora. Shines in the sky only a few lucky nights, like the Milky Way spilled across the night for the team, aurora. Let's go team, aurora.
Can you still remember the first time you enjoyed watching the sky with your loved ones? Did you enjoy how the cold wind touches your skin? Did you find it amazing how humid the air is when you're enjoying yourself on a nice weather on the beach? And have you ever wondered how a world would be without wind, clouds, temperature, and humidity? Today, we are going to explore about the concept of temperature, clouds, wind, and humidity in the atmospheric cycle. Therefore, make sure to find a good connection, sit back, relax, fasten your seatbelts, keep your gaze and ears with us, because Team Aurora is going to fly with you, and we will make sure that you will have an informative journey with us, that before we land on our final destination, you'll be equipped with the knowledge about temperature, wind, clouds, and humidity in the atmospheric cycle. Again, this is Irene, your captain for today, and thank you for choosing to fly with Team Aurora.
Good day everyone. I'm going to discuss about the atmospheric temperature and the many factors relating to it. So what is atmospheric temperature? It is a function of the modification of solar radiant energy by air, clouds, land, sea, and other water surfaces. There are frequently asked questions like, is there a difference in temperature in the atmosphere, or how does the temperature affect the atmosphere? Now let's answer these questions. The atmosphere can be divided into layers based on its temperature as shown in the picture. These layers are the troposphere, the stratosphere, the mesosphere, and the thermosphere. A farther region beginning about 500 km above the Earth's surface is called the exosphere. The line in the figure below shows how temperature varies with height. The scale on the right shows the pressure. For example, at a height of 50 km, the pressure is only about 1,000th of the pressure of the ground. Now, see the difference in temperature based on every layer of the atmosphere. First is the troposphere. This is the lowest part of the atmosphere, the part where we live in. It contains most of our weather, clouds, rain, snow. In this part of the atmosphere, the temperature gets colder. You can see the arrow down on the picture. As the distance above the Earth increases by about 6.5 degrees Celsius per kilometer, the actual change of temperature with height varies from day to day depending on the weather. The troposphere contains about 75% of all the air in the atmosphere and almost all of the water vapor, which forms clouds and rain. The decrease in temperature with height is a result of the decreasing pressure. If a parcel of air moves upward, it expands because of the lower pressure. When air expands, it cools, so air higher up is colder than air lower down. The lowest part of the troposphere is called the boundary layer. This is where the air motion is determined by the properties of the Earth's surface. Turbulence is generated as the wind blows over the Earth's surface, and by thermals rising from the land as it is heated by the sun. This turbulence redistributes heat and moisture within the boundary layer, as well as pollutants and other constituents of the atmosphere. Second is the stratosphere. This extends upward from the tropopause to about 50 km. It contains much of the ozone in the atmosphere. The increase in temperature with height occurs because the absorption of ultraviolet radiation from the sun by this ozone. Temperatures in the stratosphere are highest over the summer pole and lowest over the winter pole. By absorbing dangerous UV radiation, the ozone in the stratosphere protects us from skin cancer and other health damages. However, chemicals called CFCs or freons and halogens, which were once used in refrigerators, spray cans, and fire extinguishers, have reduced the amount of ozone in the stratosphere, particularly at polar latitudes, leading to the so-called Antarctic ozone hole. Third is the mesosphere. This region above the stratosphere is called the mesosphere. Here, the temperature again decreases with height, reaching a minimum of about negative 90 degrees Celsius at the mesopause. Fourth is the thermosphere. The thermosphere lies above the mesopause and is a region in which temperatures again increase with height. This temperature increase is caused by the absorption of energetic ultraviolet and X-ray radiation from the sun. The thermosphere is often considered the hot layer because it contains the warmest temperature in the atmosphere. Temperature increases with height until the estimated top of the thermosphere at 500 km. Temperatures can reach as high as 2000 Kelvin or 1727 degrees Celsius in this layer. However, because the air is so thin, our bodies would not be able to detect this heat. Our bodies rely on the constant bombardment of air molecules to detect temperature. The air is so thin that a molecule will travel 1 kilometer before striking another molecule. At the top of this thermosphere, molecules will move 10 kilometers before striking another molecule. At this height, many lighter molecules have attained enough velocity to escape Earth's gravity into outer space. The region where air molecules escape is known as the exosphere. Now that we already know the difference in temperature per layer of the atmosphere, let's see how temperature affects the weather. The most basic thing to understand is that warm air wants to rise while cold air wants to sink. Hot air contains fewer molecules per cubic meter, while cold air contains more. Hence, the warm air will rise up over colder air. The most common example of this is the existence of hot or cold front. These fronts are simply boundaries between hot and cold air. As the sun heats the earth, it causes water on the surface to evaporate. The evaporated water is absorbed by warm air and rises, creating clouds. The greater the evaporation, the more clouds that are created. At the same time, if conditions on the Earth's surface are warm or hot, this is a rise in the ambient humidity. When you have a high humidity and a front moving across it, the motion causes the formation of rainstorms, thunderstorms, snowstorms, and etc. Now, how temperature affects low and high pressure area. Look at air and its pressure first. Though you can't see them, air is a cocktail of molecules that fly around and bump into each other. Think of the molecules as billiard balls. As they bump into each other, they push each other around. You aren't going to notice one molecule bumping into another one, but if you add up all these tiny collisions and pushes, you might start to feel it. Those molecules also have weight, and between the weight of the air pushing down and the collisions between molecules, we get air pressure. So, how does air pressure relate to temperature? Well, remember how I said the air molecules are moving around, bumping into each other? If they move faster, they bump into each other harder and more often. This happens when the temperature of air is increased. Warm air molecules have more energy, so they have faster and create more pressure. Likewise, cold air has less energy and therefore exerts less pressure on its surrounding. Where you have a cold or hot, dry area, a high pressure system is formed. The air in a high pressure area moves clockwise. In a low pressure area, humid air with lots of clouds, there is a counterclockwise motion of air. There is a constant battle between high and low pressure system going on all over the earth, which in turn causes our weather. So, warm air is less dense and has a lower pressure associated with it. As the sun hits the ground, the air near the ground's warm. Remember, heat is less dense than cold air, so the warm air will rise. This rising motion creates a natural vacuum, lowering the air pressure at the Earth's surface. With low pressure, air rises, cools, and condenses into storm clouds, which may lead to a rainy day. Since the rising column of air weighs less, the air pressure is lower. Think back to our water cycle lesson. Water vaporizes, cools, condenses into a cloud, and later produces a rain. So now that we already know how the temperature affects the atmosphere, let's know what are the factors that affect the temperature. First is the altitude. The height measured from the sea level is called the altitude. At low altitude, there is a thick mass of air which can absorb a sufficient amount of sun heat, so it is hot at low altitude. However, when the altitude increases, the temperature also gradually decreases. Therefore, at high altitude, there is a very thin of mass which can absorb sufficient amount of sun heat. So it is cold at high altitude. The temperature decreases by 1 degree Celsius when the altitude increases by 160 meter or 165 meter. Second is the latitude. It's one of the most important factors that affect the climate of a particular place. When the latitude increases, the distance from the sun also increases, so the temperature gradually decreases. The equator lies very near from the sun, so direct rays fall over there and it is very hot throughout the year. But poles lie far from the sun, so slanting rays fall over there and it is very cold. Third is the oceanic current. The movement of oceanic water depends upon a sea breeze and temperature. This keeps on flowing on the bank of the ocean, which is called oceanic current. The equatorial region is very hot, so the air coming from this region is warm. The air coming from the polar region is cold, so the area where there is a warm current, we find a warm climate there. Similarly, the area where there is a cold current, we find cold climate there. Fourth is the distance from the sun and the ocean. During summer, the earth lies near the sun, so the perpendicular sun rays fall over there. The water of sea or ocean gets heated and cools down slowly in comparison to the land. In comparison with water, land gets heated faster and cools down fast. As the distance from the sea or ocean increases, the temperature increases. During summer, due to the direct fall of sun rays over the sea or ocean, the water is evaporated that causes the highest rainfall in the season. During winter, the earth lies a little bit far from the sun, so slanting sun rays fall on the earth. As we know that water absorbs more heat than the land, so when the distance from the sea or ocean increases, the temperature gradually decreases as the land cools down fast. Due to less slanting rays during winter, less rainfall takes place as the evaporation takes place, due to which the days in the winter. Now, what are the instruments that measure the temperature of the atmosphere? First is the thermohygrograph. an instrument which records the environmental temperature and humidity at the same time, usually both continually. Third is thermometer. It measures how hot or cold the atmosphere is in Celsius or Fahrenheit. A traditional thermometer consists of mercury, red spirit or green spirit in a glass tube, and operates on the principle that the liquid expands more than the glass does when heated. So how air temperature is measured? Temperature is usually expressed in degrees Fahrenheit or Celsius. 0 degrees Celsius is equal to 32 degrees Fahrenheit. Room temperature is typically considered to be 20 to 25 degrees Celsius or 68 to 77 degrees Fahrenheit. A more specific way to describe temperature is in the standard international unit Kelvin. 0 degrees Kelvin is called absolute zero. It is the coldest temperature possible, and is the point at which all molecular motion stops. It approximately equal to negative 273 degrees Celsius and negative 460 degrees Fahrenheit. Why temperature is important in meteorology? Air temperature affects the growth and reproduction of plants and animals, with warmer temperature promoting biological growth. Air temperatures also affects nearly all other weather parameters. For instance, air temperature affects the rate of evaporation, relative humidity, wind speed and direction, precipitation patterns and types such as whether it will rain, snow, or sleet. So that's all for the atmospheric pressure.
Good afternoon, everyone. Today's lesson will be about humidity. Do you have any idea what is a humidity? Have you ever wondered why you feel sticky over a hot weather? Or why do you feel hotter than the actual temperature? Your hair even looks freezy and feels dry. Well, it's not the heat, it's the humidity. Well, to understand humidity, you first have to realize that there's water in the air all around you. But I'm not wet, you may ask. But yes, most of the air around you has water, but in a gaseous form called water vapor. And what is the relationship between the water vapor and humidity? What is humidity then? Humidity is referred to as the concentration of water vapor in the air. This happens because of constant evaporation and condensation cycle of water. Now remember, the more water that evaporates in an area, the more water vapor is in the air. More water vapor means a higher humidity, and that higher humidity results to a higher chance of condensation and precipitation. Now, how do we actually measure humidity? Are there any instruments used? Well, yes. These are the instruments that is used to measure humidity: the psychrometer and the hygrometer. Psychrometer uses the latent heat of vaporization, while the hygrometer indirectly measures humidity by sensing the changes in physical and electrical materials due to moisture content. When we talk about humidity, there are these two primary measurements always being involved. These are the absolute humidity and the relative humidity. Now, what's the difference between the two? Let's find out. Absolute humidity is defined as the total mass of water vapor present in a given volume or mass of air. It does not take temperature into consideration, which means that it is very independent of temperature. So when we say that the temperature fluctuates or changes, whether it rises or drops, the absolute humidity is not affected. This measurement is mostly expressed in grams per cubic meter and is described as the most accurate since the amount of water vapor in the air directly determines humidity. But as accurate as absolute humidity may be, It's expressed in grams of moisture or water vapor per cubic meter of air. So when I say, for example, 5 grams of water vapor per cubic meter of air, you will still ask, how humid is 5 grams of water vapor per cubic meter of air, right? So it doesn't give you a great idea of how humid it feels outside. And that is where the second term comes in. Relative humidity. So before we go directly to the term, let us first define what is a dew point, because this dew point is used to calculate relative humidity. So dew point is the temperature the air must be for water to condense and evaporate at the same rate. Now this relative humidity is defined as the water vapor concentration or saturation relative to the maximum saturation of the air given a temperature. It is expressed in percentage and is commonly used in forecasting weather. So aside from that, relative humidity measures also how close the air temperature is to the dew point. And when the air temperature is higher, it means that it is near to reaching the dew point. And that dew point could be an indicator if there will be a cloud formation or precipitation. No relative humidity again. This method of reporting is considered relative because it isn't actually measuring how much water vapor is in the air in general, because that's the job of absolute humidity, right? So instead, it's measuring how much water vapor is in the air relative to how much that volume of air is capable of holding. To better understand this concept, look at the diagram. For example, so the container there represents the volume of air. So when the water vapor is at the center of the container, it means that the relative humidity is around 50%. But if that container is full or filled fully by a water vapor, then it means that the relative humidity is 100%. Now, take note that if the relative humidity has reached 100%, it means that that volume of air can no longer hold any more water vapor because it is already concentrated and saturated. Now, unlike absolute humidity, the relative humidity is highly influenced by temperature because the temperature determines how much space is in the air that the water vapor can occupy. So the warmer the air becomes, the more water vapor it can hold. And the cooler the air becomes, the lesser the water vapor it can actually hold. So to understand this, let us look for this example. Now, for example, take note that the amount of moisture or water vapor in this example is being held constant. So as you can see in the 3 pictures, all have the same amount of water vapor. So the center here is our basis, which is the humid air. Now to the left, the temperature is dropped. So as the temperature drops, the amount of water vapor the air could hold decreases. And that's why the container appears to be smaller than that of the center. Now with the same amount of water vapor and decreased capacity to hold water vapor, the relative humidity increases while the absolute humidity still stays the same. Now look at the container on your right. So the temperature is increased, so as the temperature increases, the ability of the air to hold water vapor also increases. So the container here appears to be larger than that of the center. So thus, with the same amount of water vapor in the humid air, the relative humidity decreases while the absolute humidity still stays the same. I gave this example in order for you to differentiate the absolute and relative humidity in terms of temperature influence. So again, the absolute humidity is not affected or independent of temperature, while on the other hand, the relative humidity is influenced by temperature. Now let me ask you a question. How does humidity affect us in a hot weather? Well, yes, in hot weather, A rise in relative humidity increases the apparent temperature, especially to humans, by hindering evaporation of our perspiration. Now, we perspire in order for us to regulate our body heat. Our perspiration is our means of removing the excess heat in our body, which is in a form of sweat. So, with higher humidity, our sweat cannot easily evaporate since there is already a higher concentration of water vapor in the air. So, for example, the forecasted weather air temperature is 27.6 degrees Celsius, and with 75% relative humidity, it would feel like 30.3 degrees Celsius. It's very far from the actual temperature, right? Now that we are done with how the humidity affects us on a hot weather, what happens to humidity in terms of temperature change, let us proceed to the importance of studying humidity. Do you think that there is an importance of the presence of humidity? Well, yes, there is. So, the importance of studying humidity or humidity itself. So, humidity is useful in weather forecasting and reports as it is an indicator of likelihood of precipitation, dew, or fog. It also plays an important role in surface life because it is a key determinant of what animals or plants can thrive in a given environment. It is also very useful in the water cycle and evaporative cooling mechanism of animals as well as humans. Now, the water cycle through evaporation, humidity, and condensation is the nature's way of distributing water to those who need it. And the evaporative cooling mechanism also is the other means of other animals to regulate the internal body temperature, as I have said earlier. And the third most important use of humidity is that it is very essential for the human comfort and health. So, the importance of studying humidity or humidity itself. So, humidity is useful in weather forecasting and reports as it is an indicator of likelihood of precipitation, dew, or fog. It also plays an important role in surface life because it is a key determinant of what animals or plants can thrive in a given environment. It is also very useful in the water cycle and evaporative cooling mechanism of animals as well as humans. Now, the water cycle through evaporation, humidity, and condensation is the nature's way of distributing water to those who need it. And the evaporative cooling mechanism also is the other means of other animals to regulate the internal body temperature, as I have said earlier. And the third most important use of humidity is that it is very essential for the human comfort and health. So before I end this discussion, let me add another idea or an insight. If water vapor would not evaporate and humidity is absent, we wouldn't have any clouds and it would never rain. Without water vapor in the air, our weather might be like the weather on Mars. Now, could you imagine life without clouds, rain, snow, lightning, or even thunder? Well, I guess your answer would be no, because life will be totally different. So thank you for listening. I hope that this discussion of mine help you better understand what is humidity. Once again, this is Yanisa Joyce Mabutas. Stay tuned for another fountain of information. Thank you and God bless.
Good morning, everyone. For today's discussion, we will discover about clouds, its types, formation, and many more. How's the weather for today in your area? Do you see clouds? Are you excited for today to know more about clouds? Okay, so let's start. What is clouds? Clouds is a mass of water drops or ice crystals suspended in the atmosphere. How does cloud form? Clouds form when moist, warm rising air cools and expands in the atmosphere. The water vapor in the air condenses to form tiny water droplets, which are the basis of clouds. It forms in the process of evaporation and condensation. Water vapor gets into air mainly by evaporation. The liquid water from the ocean, lakes, and rivers turns into water vapor and travels in the air. When air rises in the atmosphere, it gets cooler and is under less pressure. When air cools, it's not able to hold all of the water vapor it once has. Air also can't hold as much water when air pressure drops. The water vapor becomes small water droplets or ice crystals, and a cloud is formed. The next process is water vapor condenses to form a cloud. The water vapor is easier to condense into water droplets when it has a particle to condense upon. These particles, such as dust and pollen, are called condensation nuclei. Eventually, enough water vapor condenses upon piece of dust, pollen, or other condensation nuclei to form a cloud. And also, sun plays a major role in producing clouds. Clouds form in different way or process. Clouds form as air warms up near the Earth's surface and rises. Example is cumulus, cumulonimbus, and stratocumulus clouds. Clouds form when wind blows into the side of a mountain range or other terrain and is forced upward higher in the atmosphere. Example is stratus clouds. Then the third one is clouds also form when air is forced upward at areas of low pressure. And in this process, all types of clouds are formed. Then the last one is weather fronts where two large masses of air collide at the Earth's surface also form clouds by causing air to rise. How do clouds affect climate? Clouds affect climate in two major ways. First, they are an essential part of the weather cycle. Clouds provide an important link between the rain and snow, oceans and lakes, and plants and animals. Then, second, clouds also have an important effect on Earth's temperature. Clouds can both cool down and warm up the temperature on Earth. During the day, clouds can make the temperature on Earth cooler by blocking heat from the sun. At night, clouds can make Earth temperature warmer by trapping heat that came from the sun. Clouds are classified according to the level of their base, and it has three classifications of clouds. First is high-level clouds, second, middle-level clouds, and the third one is low-level clouds. High-level clouds is due to cold tropospheric temperatures at these levels. The clouds primarily are composed of ice crystals and often appear thin, streaky, and white. It occurs above 20,000 feet, and it has prefix circo. It has three main types: cirrus, cirrostratus, and cirrocumulus. Middle-level cloud depend on the altitude, time of year, and vertical temperature structure of the troposphere. These clouds may compose of liquid water droplets, ice crystals, or a combination of the two, including the supercooled droplets. It is found in the middle level of the troposphere. It has a prefix of alto, and it appears between 6,500 to 20,000 feet. It has two main types: altostratus and altocumulus. Then the last classification of clouds is the low-level clouds. Low-level clouds are not given a prefix, although their names are derived from strato or cumulo depending on their characteristics. It is below 6,500 feet and it has two main types: stratus, which develop horizontally, and cumulus, develop vertically.
In this chapter, we will talk about the types of clouds. What are the types of clouds? Do you know one? Okay, that's great. The first type of clouds are cirrus clouds. The cirrus clouds are delicate, feathery clouds that are made mostly of ice crystals. Their wispy shape comes from wind currents which twist and spread the ice crystal into strands. The second type of clouds are cirrostratus clouds. The cirrostratus clouds are thin, white clouds that cover the whole sky like a veil. These clouds are mostly commonly seen in the winter and can cause the appearance of a halo around the sun or the moon. The third type of clouds is the cirrocumulus clouds. The cirrocumulus clouds are thin, sometimes patchy, sheet-like clouds. They sometimes look like they're full of ripples or are made of small grains. Altocumulus clouds. The altocumulus clouds have several patchy white or gray layers and seem to be made up of many small rows of fluffy ripples. They are lower than cirrus clouds but still quite high. They are made up of liquid water but they don't often produce rain. Altostratus clouds. The altostratus clouds are gray or blue-gray mid-level clouds composed of ice crystals and water droplets. The clouds usually cover the entire sky. The nimbostratus clouds. This type of clouds are dark gray clouds that seem to fade into falling rain or snow. They are so thick that they often blot out the sunlight. Cumulus clouds. The cumulus clouds look like fluffy, white cotton balls in the sky. They are so beautiful in sunsets, and their varying sizes and shapes can make them fun to observe. The stratus clouds. This type of clouds often look like thin, white sheets covering the whole sky. Since they are so thin, they seldom produce much rain or snow. Sometimes, in the mountains or hills, these clouds appear to be fog. The cumulonimbus clouds. This type of clouds grow on hot days when warm, with air rises very high into the sky. From far away, they look like huge mountains or towers. Stratocumulus clouds. This type of clouds are patchy gray or white clouds that often have a dark honeycomb-like appearance. Try to observe the different types of clouds that we commonly see in the troposphere. In addition, there are special cases where clouds may form or grow as a consequences of certain, often localized generating factors, and that what we call the special clouds. There are four types of special clouds. The first one is the mammatus. This type of clouds are actually altocumulus, cirrus, cumulonimbus, or other types of clouds that have these pouch-like shapes hanging out of the bottom. The pouches are created when cold air within the cloud sinks down towards the earth. The second one is the lenticular clouds. This type of clouds are shaped like lenses or almonds or flying saucers. They may get their shapes from hilly terrain or just the way the air is rising over the flat terrain. Orographic clouds. This type of special clouds get their shape from the mountains or hills that force the air to move over or around them. They can also be formed by sea breezes and often appears as lines where two air masses meet. The last type of special cloud is the cone trails. This type of special clouds are made by high-flying jet airplanes. They are still clouds, though, because they are made of water droplets condensed from the water vapor and the exhaust of the jet engines. What role do clouds play? Clouds play a vital role in our climate by regulating the amount of solar energy that reaches the surface and the amount of the Earth's energy that is radiated back into space. The more energy that is trapped by the planet, the more warmer our climate will grow.
Good day everyone, I am Irene S. Chavez and today I will talk about wind. But before the discussion proper, let me ask you a question. So what comes into your mind when we talk about wind? So maybe most of you use the word air and wind interchangeably. Now, let me give clarification of how it differs from each other. Air is a gaseous mixture in the atmosphere which includes oxygen, carbon dioxide, and nitrogen, while wind is the horizontal motion of air. What is wind? Wind is a moving air and is caused by differences in air pressure within our atmosphere. Air under high pressure moves toward areas of low pressure. The greater the difference in pressure, the faster the air flows. It follows some definite patterns due to solar energy and air temperature differences that affect air densities and pressures. Warmer air is less dense than cooler air. Therefore, it rises and cooler air moves in to take its place, resulting in wind. Wind has important characteristics: the direction and speed. These two characteristics are measured by scientific instrument that will be discussed on the next slide. What are the instruments used for measuring wind? First, we have wind vane. It is an instrument used to measure the direction of the wind. It has two parts, the front and the rear. This is then mounted on a vertical column that is free to move when the wind blows. The first part has a smaller surface area than the rear. When wind blows, it presses more on the rear part of the wind vane as it has greater surface area. The arrow, therefore, aligns itself such that its tip points in the direction from which the wind is blowing. Directions, namely north, south, east, west, etc., will be marked on the wind vane. Next, we have anemometer. It is an instrument used to measure the speed of the wind. In a type of anemometer called cup anemometer, there are 3 or 4 cups mounted symmetrically at right angles to vertical axis. The rate of rotation is directly proportional to the wind speed. The faster the wind speed, the faster the cups rotate. Lastly, we have barometer. It is a scientific instrument that is used to measure air pressure in a certain environment. Pressure tendency can forecast short-term changes in the weather. Now, let's tackle on the different wind patterns. So what are the different wind patterns? There are 4 major wind systems and wind belts, but now let's focus on the 4 major wind systems.
First, we have polar easterlies. Polar easterlies can be found at the north and south poles, and they are cold and dry because of where they are located. This type of wind system forms when cool air at the poles and then transfers to the equator. Polar easterlies are located 60 to 90 degrees latitude in both the southern and northern hemispheres. Second, we have tropical easterlies. Tropical easterlies take direction in an east-west flow because of the rotation of the Earth. As air from the equator rises, it gets warmer, and when it cools down, it comes back to the equator. Tropical easterlies are located 0 to 30 degrees latitude in both hemispheres. Third, we have prevailing westerlies. Prevailing westerlies are located in the 30 to 60 degrees latitude in the northern and southern hemispheres. They blow from east to west and occur in the clement part of the earth. And lastly, we have Intertropical Convergence Zone, or ITCZ. It is also known as the Equatorial Convergence Zone or the Intertropical Front. It forms when southeast and northeast trade winds converge in a low-pressure zone near the equator. It usually appears as a band of clouds and comes with thunderstorms, which are short but produce extreme amounts of rain.
Now let's go to the wind belts. First, we have horse latitudes. Horse latitudes, also known as the subtropical high, are about 30 to 35 degrees north and south of the equator. Horse latitudes is a region where there is weak winds because of high pressure and decreasing dry air. The origin of the name horse latitudes is uncertain, but it is said that ships that needed wind power couldn't move on the water, and the sailor threw the horses and cattle over the ship to save on provisions. Second, we have trade winds. So trade winds blow from the horse latitudes to the low pressure of the ITCZ. In the northern hemisphere, the winds blow from the northeast, which is called the northeast trade winds. In the southern hemisphere, the trade winds blow from the southeast, and they are called the southeast trade winds. Trade winds get its name from its capability of blowing trade ships across the ocean very quickly.
Lastly, we have doldrums. Doldrums is the same thing as the Intertropical Convergence Zone. It takes place 5 degrees north and south of the equator and between the two belts of trade winds. When the trade winds converge, it produces convectional storm. This name originated from some sailor who noticed the stillness in the rising air and called it doldrums, which means depression or despondency. Now let's talk about the factors affecting wind motion. So the direction and speed of wind are controlled by a number of factors. These are the pressure gradient, the Coriolis effect, the centripetal acceleration, and friction. First, we have the pressure gradient force. This is the force generated due to the differences in horizontal pressure, and it operates from the high pressure area to a low pressure area. Since a closely spaced gradient implies a steep pressure change, it also indicates a strong wind speed. The wind direction follows the direction of change of pressure. Second, we have the Coriolis force. Due to the Earth's rotation, winds do not cross the isobars at right angles as the pressure gradient force directs, but deflected from their original path. This deviation is the result of the Earth's rotation and is called the Coriolis effect or Coriolis force. Due to this effect, winds in the northern hemisphere get deflected to the right of their path and those in the southern hemisphere to their left. The Coriolis force changes wind direction but not its speed. This deflection force does not seem to exist until the air is set in motion and increases with wind velocity, air mass, and an increase in latitude. The third factor is the centripetal acceleration. Due to the inward acceleration of air towards the center of rotation on the rotating Earth, it is possible for the air to maintain a curved path about a local axis of high or low pressure. The last factor that we are going to tackle is the frictional force. The irregularities of the Earth's surface offer resistance to the wind motion in the form of friction. This force determines the angle at which air will flow across the isobars, as well as the speed at which it will move. It may also alter wind direction. Over the relatively smooth ocean surface, the friction is minimum, so the air moves at low angles to the isobars and at a greater speed. Over uneven terrain, however, due to the high friction, the wind direction makes high angles with isobars and the speed gets retarded. To discuss further about how wind affects weather or climate, I'll give you to Marichel Dihito.
Wind in climatology, the movement of air relative to the surface of the earth. Winds play a significant role in determining and controlling climate and weather. So, how wind affects weather and climate? The first one is the Coriolis effect. If it were not for the Earth's rotation, the wind would simply flow in relatively straight paths from north to south or from south to north, respectively. But the Earth does rotate, and as a result, the wind and weather patterns are reflected to the right in the northern hemisphere and to the left in the southern hemisphere. The second one is sea and canyon. Localized winds like those found along a coastline are created by similar forces. As the sun rises, the water and the land absorb the sun's heat at different rates. As a result, high and low pressure systems are created. In the morning, the land will heat up faster than the water. As the land heats up, it radiates heat to the surrounding area. Second, highs and lows. Within the mid-latitudes, weather effects create high and low pressure zones, called highs and lows respectively. Air moves from areas of high pressure to low pressure. As it moves, however, it spirals due to the Coriolis effect, producing the shifting winds we experience from day to day. As highs and lows drift under the influence of the prevailing westerlies, winds reaching the center of a low-pressure area have nowhere to go but up. This causes moisture to condense into clouds, producing storms. At the center of high-pressure areas, dry air descends from above, producing fair weather. Next is wind and weather. As a result of the movement of atmospheric materials transported by wind, driven by the energy from the sun, climates are created and weather occurs. Without wind, weather would not exist. Wind, in its interdependent relationship with the other cycles of the earth, like ocean currents, is the vehicle by which water vapor and by consequence, temperature variations are moved from one area of the globe to another, creating weather variations with specific climate zones. Events or situations that caused by winds. The first one is extreme winds. There is no widely accepted definition for extreme wind. In the context of building design, an extreme wind is a wind gust which is strong enough to be dangerous for people or cause significant damage to buildings and property. The second one is tornadoes. A tornado is a large rotating column of air that occurs in association with a thunderstorm. It has winds that travel at a very high speeds around a central area of very low atmospheric pressure. Extreme wind gusts are the result of intense turbulence within vigorous storm systems such as ex-tropical cyclones or mid-latitude storms. These systems contain bands of generally strong winds associated with areas of large pressure gradients, and these are usually near the center of low pressure. Organized convection, Wind shear and steep terrain within these bands can all generate the turbulence that gives rise to the extreme wind gust. Extreme winds can on occasion also be caused by tornadoes and convective downbursts from isolated thunderstorms not associated with a large storm systems. Potential consequences of extreme winds and tornadoes. Extreme winds and tornadoes can cause deaths and property damage, with the damage being highly unpredictable. Typical damage experienced caused by these phenomena includes destruction of buildings and houses, including roofing being blown off, broken windows, and other flying debris. Second, large-scale forest damage and fallen trees or branches falling onto power lines. Third, high-sided vehicles and outdoor equipment such as center pivot irrigators being blown over. And worst, very tall buildings, suspension bridges, and transmission lines can suffer structural failures. What is the importance of studying wind speed, and wind direction? The first reason is, if you know the wind speed and direction, you will know what direction the weather is coming from and how fast it is moving. For example, if it is raining at a town 18 nautical miles to the west of a second town and the radar returns show that the precipitation is moving to the east at a speed of 20 knots. A relatively accurate prediction for the second town is that in 4 hours' time it will be raining. So, the plot shown below shows how plotting the wind can show you the location of the pressure center. The thing to remember is that sometimes measuring situations are more than 100 miles apart, so plotting the wind like this can really help. Second, if we didn't have any winds in the atmosphere, it would be extremely hot in the tropical regions and extremely cold in the northern regions. Why? Because the wind is a very effective transport of energy, similar to the draft we may get in the house for having a window and a door open. By opening a window, we get the air flowing and lower temperature in the house. Last, the wind clearly plays an important role in weather forecast. But not only it is important for planning our daily lives, it is also vital for many commercial activities such as farming, fishing, transport, and for taking appropriate measures when extreme weather is on the horizon.
Thank you for listening and watching. I hope you've learned something today. Once again, this is Team Aurora. Thank you for flying with us.